Hi, kids. All right, so let's go back to Kepler's third law, and I want to show you how super cool and awesome this is to actually use. So, what was Kepler's third law again? All right, well, I say, shoot, I don't remember. So, we're going to derive it again because I just want to show you how fast you can derive it. So, first step, draw your picture. Hey, look, I have the thing orbiting around. Second step is to write your equation. Fg equals Fc, Gmm over r squared equals mv squared over r. Little m cancels because that's the mass of my planet cancels. One of the r's goes away. Oh yeah, this is going to be 2 pi r over t. So I do some algebra and I square 2 pi. Square 2, you get 4. Square pi, you get pi squared. Square r, you get r squared. Square t, you get t squared. Oh, and then you get gm over 4 pi squared equals r cubed over t squared. Oh yeah, that means that r cubed over t squared is going to be a constant for a given system. So for a given system, this, and this is always the same. Okay? And you see, that took me, I don't know, 30 seconds to derive. So you are not going to memorize it. You're going to understand it. Okay? Now, if we are using 6.67, then we are using standard units, which are kilograms, meters, seconds, which honestly makes this kind of a pain in the butt. Because do I really want to know, like, how many seconds it takes some random asteroid to orbit the Earth? The answer is no. Okay? So, most of the time, I would probably want to know, like, how many years it takes an asteroid. So, let's use different units. Okay? So, we're going to set something up where we're going to solve it using different units. Well, and this is where astronomers were smart. They said for the Earth, they're going to call the average distance from the sun, if this is the Earth, they're going to call it 1 AU, okay? And AU stands for an astronomical unit, which really is the average distance from the Earth to the sun. Okay. Now, if it was in miles, it would be 93 million miles. But that's not what they're doing. They're saying 1 AU. Okay. So just like, hey, I could measure this sheet of paper and tell you how far across, this is 8 inches from here to here. I could tell you how many centimeters that is. It's measuring the same thing, just different units. Okay. So in this case, 1 AU. So if this was the Earth, well then my R is equal to 1 AU. Well, all right, so that would be 1 cubed. And then let's come up with a nice, easier unit for the time rather than seconds. How about a year? So, oh yeah, that would be 1 year. So I would have 1 squared. So if I have 1 AU cubed, 1 cubed, let me think. 1 cubed, 1 times 1. Oh yeah, that's 1. And 1 squared, that's also 1. So I would get 1. Now my units would be a little bit weird. They would be like AU cubed and years squared. But who cares? I get 1. 1 is a super wonderful, easy unit to, or number to work with. So let me show you how cool this is. Okay, the planet Saturn has an average distance from the sun that's about, I hope I do this right, I think it's about 10 AUs. I'm doing this off the top of my head, which means Saturn is on average 10 times farther away from the sun than the Earth is. So let's figure out Saturn's period. Okay, so Saturn is 10 AUs. So if we want to figure out Saturn's period, okay, then what you would do is you would say, well, r cubed over t squared equals 1. Well, r is really going to be 10 cubed over t squared. So you take out your calculator because you don't have to do this in your head, but I end up with t squared equals 10 cubed is 1,000. Well, if I take the square root of 1,000, I get just over, it's like 31.6 years. So that means it takes Saturn 31.6 years to go around the Earth, or sorry, go around the Sun every single year. For like that's the length of the Saturn year. Okay, but isn't that cool? Isn't that nice and easy how that works? So if I have, for example, Halley's Comet, okay, Halley's Comet orbits the Earth, the Sun. Sorry, I'm for some reason I keep saying orbits the Earth. Orbits the Sun every 76 years. So if I was to set this up, well, if it orbits it every 76 years, I would have that squared, and then I could figure out what is the R. Well, 76 squared is going to be a big number, that number, okay? And then if I raise that to the 1/3 power, that means on average it is just under 18, so 17.94 AUs. On average, the Halley's Comet is that far from the Sun. Does that mean it's always that far from the Sun? No, because it's really an elliptical path. But that's pretty cool. Okay. All right. You should be able to finish the rest of that worksheet now. Bye, kids.